Hello everyone, and welcome back to another daily LeetCode challenge. Today's problem is LeetCode 2110, number of smooth descent periods of a stock. You're given an integer array called prices, where prices I represents the stock price on the IH day. A smooth descent period is defined as a sequence of one or more contiguous days. In this sequence, the stock price on each day must be exactly one less than the price on the previous day. The first day of any period is always valid and does not need to follow this rule. Your task is to count all possible smooth descent periods in the given price history. This includes single-day periods and longer periods where the price decreases by exactly one each day. Finally, return the total number of such smooth descent periods. Let's go through some examples next to make this definition clearer, and then we'll break down an efficient solution. Example 1. Let's look at an example to understand this better. The input array is 3, 2, 1, 4. The output is 7, meaning there are 7 smooth descent periods. First, every single day by itself counts as a smooth descent period, so we have 3, 2, 1, and 4. That's 4 periods already. Next, we look for consecutive days where the price drops by exactly 1. 3, 2 is valid because 2 is exactly 1 less than 3. 2, 1 is also valid for the same reason. Finally, the entire sequence 3, 2, 1 forms a smooth descent period. If we count all of them together, we get 7 smooth descent periods. That's why the final answer is 7. Example 2. Now let's look at the second example. The input array is 8, 6, 7, 7. The output is 4. Each individual day forms a smooth descent period. So we have 8, 6, 7, and 7. However, there are no valid multi-day periods here. For example, 8, 6 is not valid because the price drops by 2, not by 1. Similarly, 6, 7 increases, and 7, 7 stays the same. Both are invalid. So the total number of smooth descent periods is 4. Example 3. Now let's look at the third example. The input array contains just one element, 1. A single day always counts as a smooth descent period, so the total number of smooth descent periods here is 1. That's why the final answer is 1. Now let's break down this Python solution line by line and understand how it counts all smooth descent periods efficiently. Function definition. We start with the function getDescentPeriods, which takes the array prices as input. Our goal is to count all smooth descent periods in this array. Variable initialization. Sum des prev equals 0, 0, 0, minus 1. Here we initialize 3 variables. Sum keeps track of the total number of smooth descent periods. Des stores the length of the current smooth descent sequence. Prev keeps the value of the previous day's price. We initialize prev to -1, so the first comparison always fails, which correctly starts a new sequence, iterating through prices. For x in prices. Here, we loop through each stock price one by one. At each step, we decide whether the current price continues a smooth descent or starts a new one. Core logic, detecting smooth descent. Des equals negative all equals prev and des plus 1. This is the most compact part of the solution, so let's simplify it conceptually. What this line means: if the current price x is exactly 1 less than the previous price, then we extend the current descent. Otherwise, we reset the descent length. X plus 1 equals prev checks whether prev x equals 1. If true, the descent continues. If false, the descent breaks. This bitwise operation is a clever way to say continue the descent if valid or reset it if not. After that, we add 1 to count the current day itself. So des always represents the number of valid smooth descent periods ending at the current day. And finally, accumulate the result, sum plus equals des. Every valid descent ending at the current index contributes to the total. So we add des to sum. Then update previous price. Prev equals x. We update prev so the next iteration can compare correctly. And finally, we return sum. After processing all prices, we return the total count. All right, now let's go ahead and run the code. Nice, all the test cases passed successfully. The logic works perfectly for both small and large inputs. Now it's time for the final step. Let's hit submit. And there we go, accepted. All test cases passed. That wraps up today's daily LeetCode challenge. If this explanation helped you, don't forget to like the video, subscribe to the channel, and share it with anyone preparing for coding interviews. I'll see you in the next problem. Happy coding!